Hi, this is Lakshmi Narayanan, Siddharth Institute of Science and Technology, Puttur, EC department. Okay, now I'm going to talk about analog communications. First, let me talk in general the overall block diagram of communication system. Now, I'm going to talk about overall block diagram of any communication system. Before that, first of all, what is communication? So, the process of transferring information from one place to other place is known as communication. That is exchange of information. Say, for example, something I am talking, here information is nothing but voice signal. So this voice signal, I should transmit from, say, for example, Puttur to somewhere at Chennai. That's what communication means. So I may transmit voice signal or electrical signal, so or video signal or some text data, whatever it might be. So that is to transmit voice signals, generally we will go for telephone systems. To transmit audio signals, generally we will go for radio systems. To transmit video signals, generally we will go for TV systems. Either radio or telephone or video, whatever it might be. In general, what is the overall block diagram of any communication system? Let me discuss that first. Okay. So now here if you observe the overall block diagram of any communication system, this is what. It consists of information source, input transducer, transmitter, channel, receiver, output transducer, destination. These are the things we are going to get. So that is including we are saying transmitter, channel and receiver. Okay, this overall block diagram, let me discuss in terms of voice signal first. See first, that is to transmit voice signal, we'll go for telephone systems. Okay, so that is, so to transmit my voice signal, I'm going for telephone system in the sense, say for example, something I'm talking here. So whatever I'm talking in Puttur, that I should transmit to Chennai. Okay, transmitter is at Puttur, receiver is at Chennai. Okay, so now here if you observe, listen ma, now here if you observe, so my transmitter is at Puttur. Okay, so transmitter consists of information source, input transducer, and transmitter here is nothing but modulator. So first block here information source. Information source. Here if you observe what is information source in the sense, listen here. Information source is nothing but something I am talking in the sense information voice signal. For video signals, information is nothing but video. And for text data, information is nothing but some data you are going to get. That's what information source. Okay. So the output of information source is passed through input transducer. First of all, what is a transducer in the sense? Which converts one form of energy to other form. Which converts one form of energy to other form. That's what transducer in the sense. Okay. Here, input transducer, generally transducer, which converts one form of energy to other form. Generally, from information source, we'll get non-electrical signal. To convert that non-electrical signals to electrical signal, now we are going for the concept of transducer. Okay. So voice signals, if you consider, information is nothing but voice signal, that is non-electrical signal. I should convert that one to electrical signal in the sense, observe here. So transducer. So observe now, there I mentioned it clearly, radio broadcasting and all. Okay. See, that is to convert voice or audio as an electrical signal. So we are going for microphones. Generally, we are calling mic. That mic is nothing but microphone. Microphone converts voice signals to electrical signal. Audio signal to electrical signal. Okay, ma. So that's what a transducer. Okay. So from information source, what are the data you are getting to convert that to time varying electrical signal? Now we are going for the concept of input transducer. Okay. And now the output of transducer here passed through transmitter I mentioned. So transmitter is nothing but modulator. Generally, we can call transmitter or modulator interchangeable. The same fashion, receiver or demodulator, we can interchange. Okay. So transmitter is nothing but some sort of modulator. So transmitter is nothing but some sort of modulator. I mentioned C. So in modulation, I mentioned modulation is the main function of the transmitter. Okay. So that is now here if you observe, so in modulation, what is the purpose of modulation in the sense? Modulator translates low frequency to high frequency. Something I am talking in the sense voice signal, generally I can talk around the frequency range of 300 Hz to 3.5 kilohertz. But what we are listening in radio signal, if you observe 98.3 mega, if you are asking me to talk with 98.3 mega, definitely it's not possible. So that's what. So now what I am saying in the sense, I should, at the transmitting section, I should translate low frequency to high frequency. For that purpose, we are going for the concept of modulation. Okay, ma? Okay. Modulation. That's what the main function of transmitter. And the output of transmitter, modulator, is transmitted through your channel. Is transmitted through your channel. See, channel may be anything. So different types of channels we are having. Okay. So for landline telephones, if you observe, so nowadays, for landline telephones, nowadays, if you observe, nowadays we are using fiber optic cables. Previously, we used twisted base. And for dish cable and all, if you observe, so we used coaxial cables. And so you might have seen coaxial cables, some black wires for TV purpose and all. Previously, we used. Nowadays, for cable connection also we are using. And again here, if you observe, so listen, ma. And for mobile phones, we'll use a free space as a channel. See, whatever it may be signal, whatever it may be channel. Okay, once if the signals keep on transmitted through the channel, some noise will interfere with your signal. To overcome the defect of noise, as well as to improve the signal strength along the channel, I should take some precautions. Okay, so to improve the signal quality, signal to noise ratio along the channel, definitely I should take some precautions. In analog communications, along the channel, we will use amplifiers to improve the signal strength. In digital communications, along the channel, I use regenerative repeaters to regenerate ones and zeros. That's what the concept of, that is always listen. Always my signal to noise ratio must be as high as possible always. Signal to noise ratio means signal power by noise power. If signal power is very high compared to noise power, we can extract the signal. Here I am talking something. If some external noise are disturbing, my signal power decreases, you cannot receive my voice signals. Are you getting my point? So definitely my signal power has to be very high. Then only you can listen my voice and video. Okay. So for that purpose, along the channel in analog communications, we'll use amplifiers, as well as in digital communications, we'll go for regenerative repeaters. Why? Because in digital communications, information is zeros and ones. To regenerate that zeros and ones, we are going for regenerative repeaters. That's what the concept of channel and noise. And listen, and signal is transmitted through the channel. At the receiving section, I should, whatever I am talking, if you take telephone system, whatever I am talking, that you should get back at the receiving section. That's what my intention. That is, receiver is nothing but just vice versa of your transmitter. Receiver is just vice versa of your transmitter. Okay. See, that is in the receiver, the first block is nothing but receiver I mentioned. So receiver is nothing but demodulation. I can interchangeably use the word receiver or demodulation, both same itself. See here. Receiver or demodulation, both same. See, the input for receiver is nothing but the output of transmitter, which is nothing but the electrical signal and the high frequency signal. The output of receiver, what I should get back? So I should get back non-electrical signal, that is voice signal, and low frequency signal you should get back. But receive is high frequency. So meaning that I should translate that high frequency to low frequency. The process of translating high frequency to low frequency is known as demodulation. Opposite to modulator is nothing but demodulator. Is it clear? Okay. So then again, now I got here at output of the demodulator, that is at output of the receiver. Now I got low frequency signal, which is nothing but electrical signal. At the output of receiver, you should get back voice signal, that is non-electrical signal. So that is electrical signal should be converted to non-electrical signal. To convert one form of energy to other form, always will go for the concept of transducer. So to convert electrical signal to voice signal or audio signal, generally we are saying speakers. For speakers, input is electrical signal, output is nothing but voice signal or audio signal. Generally we call speakers or loudspeakers. Okay, so that's what here output transducer. The output transducer is applied as input for destination. So what is destination here in the sense? So destination is nothing but the final stage, what I am talking at the receiving section, we are going to get back. Okay, so that's what loudspeaker, which works as a transducer and converts the electrical signal in the form of original sound signal. That's what output transducer and combination of destination. Okay, ma. So this is what overall block diagram of any communication system. If you go for different signals, different transducers we are going to use. And if you go for different signals, different modulation techniques we are going to use. I mentioned modulation is the process of translating low frequency to high frequency. That is frequency domain. In time domain, if you're asking what is modulation, The process of varying any one characteristic parameter of the carrier signal according to message signal. Okay. In time domain, if you vary any one characteristic parameter of the carrier signal according to message signal, automatically in frequency domain, low frequency translated to high frequency. That's what the concept of modulation. Now in this subject, analog communications, we are going to talk about different modulation techniques. Different modulation techniques. Amplitude modulation, frequency modulation, phase modulation, and for different things, what are the different advantages and disadvantages. Okay, if you go for AM again, DSB, SSB, BSB you are having. For video signals, we are going for vestigial sideband modulation. And for voice signals, we are going for SSB modulation. Okay, and for audio signals, nowadays audio means radio. For nowadays, audio means you take any one song. To transmit songs and all, we are going for radios. For radios and all, nowadays we are going for FM. Okay, so in depth we are going to study in analog communications, modulation and demodulation concepts. Okay, ma? This is what in general the overall block diagram of any communication system. Okay, thank you so much.